Sorry, I ran out of memory. Alright, so where I left off, we're solving this equation. We completed the square, so we could take the square root, and then we subtracted 4 on both sides. So positive 1 minus 4 is negative 3, negative 1 minus 4 is negative 5. If you plug these numbers back in, you end up with the same answer. So negative 3 squared is 9, minus 24 gives us negative 15. It works. And then negative 5, this is how you check your work. Squared is positive 25. Minus 40, this becomes 40, is going to equal negative 15. It also works. So there's our two answers. So your answer is x equals negative 3 or negative 5. This is how your teacher would probably want you to write it. Box your answers. Alright, so let's do 4 more of these. This one's a little trickier. Like I said, you start with the middle number, divide by 2 is going to give you this number, and then you square it to get the last number. So it's b divided by 2 squared equals your c. So in this case, you need to put all the other numbers aside so you can figure out what this number you want to be. So I added 1 on both sides. So our b value here is a hidden 1. There's a 1 because this is a 1x. So how do we find our c? It equals 1 divided by 2 squared. And then 1/2 squared is 1/4. 1 times 1 is 1, 2 times 2 is 4. So it's going to be like this. How much are we adding on this side? 1/4. So you need to add that on the other side. You see what I did? I should have done that in red. Oh well. And then from here, your square, this number divided by 2 is what you get your square. So like 6 divided by 2 gives us the 3 here. 8 divided by 2 gives us this 4. So our square is 1 divided by 2, which is 1/2. So that's x plus 1/2 squared equals, and then 1 plus 1/4. Your math teacher likes you to write it as an improper fraction, 5/4. From here, you could take the square root of both sides, put plus or minus in front of the number. So you get x plus 1/2 equals plus or minus the square root of 5/4. Hopefully your math teacher already taught you how to take the square root of a fraction. You take the square root of the top, which is just square root of 5, and take the square root of the bottom. Square root of 4 is 2. So then you end up with two answers. X equals, and in math we like to put the rational number in front. Subtract 1/2 from both sides. Rational numbers in front. Plus or minus square root of 5/2. Notice these have common denominators, so your teacher probably would love you if you wrote it as -1 plus or minus the square root of 5 all divided by 2. Kind of looks like quadratic formula, because you can solve these using quadratic formula, but your teacher wants you to practice completing the square. Why? Because you are going to be using it for other things like conic sections and parabolas and whatnot. Defining conic sections, all this other random stuff. Cool? 43 is trickier because now we have an a value of 3, so we want to divide out that a value because we want it to be 1. In order to complete the square, you want it to be 1. So you divide everything by 3. It's like if you had 3 plus 6 equaled 9. I do this with my students all the time. I show them a basic example. You can divide everything by 3. So 1 plus 2 equals 3, and you still have a true statement. If you don't divide everything by 3, you're not going to have a true statement. You're going to have like 1 plus 6 equals 9. Does not make sense. You need to divide everything out. Divide everything. So then you have p squared minus 4p plus 2/3 equals 0 divided by 3 is 0. Once again, move everything to one side, or anything that doesn't have a p in it to one side. Now we have this -4. How do you complete this square? It's just like this one, right? This one right here. So if this is -4, it's going to be x minus 2, and you want to see a plus 4, because the negative times the negative is going to give you a positive, just like this number right here. So we want this number to be a plus 4. If you add 4 on the left side, you need to add 4 on the right side. So then now your perfect square on the left side is p minus 2 squared. On the right side, positive 4 minus 2/3 is 3 1/3. Do we want to convert that? We probably would. 10/3. Good? Square root both sides. Anytime you take the square root of a number, put plus or minus in front of it. P minus 2 equals plus or minus square root of 10 over 3. Your teacher probably wants to see this as p minus 2 equals plus or minus square root of 30 over 3, just by multiplying the top and bottom by 3. And then square root of 9 is 3. Add 2 on both sides, so your final answer is p equals plus or minus square root of 30 over 3 plus 2. And usually we want to put the 2 in the front, but this answer is the same thing. Ta-da! Alright, 2 more. 55, same thing. We have a value of 2. We want it to be 1, so you divide everything by 2. So x squared minus 3 halves x. This one's ugly. I hate how college professors think that you guys can do this kind of stuff. Alright, from here, x squared minus 3 halves x equals 5 halves. We move the 5 halves over by adding 5 halves on both sides. And then how do you find your c value? C value equals your b value divided by 2 and squared. So 1.5 or 3 halves divided by 2 is going to give us what? 3/4? Yes. If you can't remember, 3 halves divided by 2 is the same thing as multiplying by the reciprocal, which is 3/4. 3/4, and then you square that. So 3 squared is 9, 4 squared is 16. So this needs to say plus 9/16. Really ugly, and fractions. I would never do this to my students. Maybe my honors kids. Alright, from here. On the left side you have a square now. It's going to be x minus 3/4 squared. On the right side, 5 halves plus 9/16. Your teacher probably wants you to have common denominators. Times this by 8 over 8, which is 40 over 8 plus, 40 over 16 plus, yeah, multiply that by 8 and 8, yeah, plus 9 over 16. Cool. Super ugly. Oh, it turns out nice though. X minus 3/4 squared equals 49 over 16. Take the square root of both sides. Anytime you take the square root, plus or minus in front of it. Sorry, my paper's falling. X minus 3/4, square roots cancel, equals plus or minus square root of 49 is 7, square root of 16 is 4. Add 3/4 on both sides, so x equals plus or minus 7 over 4 plus 3/4. So that equals 7/4 plus 3/4 is 10/4, or negative 7/4 plus 3/4 is negative 4/4. Final answer is x equals, simplify these two numbers, 5 halves or negative 1. Ta-da! They do not want you to factor this. Do not factor. Do not factor any of these. The directions say complete the square, so you got to do it this ugly way. Alright, last problem. Divide everything by 5. You guessed it. X squared plus 3x minus 1/5 equals 0. X squared plus 3x. Move the other one onto the other side. Leave a space so you can complete the square. How do you find that number? It's b divided by 2 squared. 3 squared is 9. 2 squared is 4. So you're adding 9/4 on both sides. So then you have our square on the left side is going to be x plus 3 halves squared equals 1/5 plus 9/4. I know that's going to be 4/20 plus times 5 is, I can't even do math right now, 45/20. Yes? So that's going to give us 49/20. Did I do that correctly? Times 5 times 5. Yeah. Times 4 times 4. Cool. Square root. Plus or minus x plus 3 halves, because the square and the square root cancel, equals plus or minus. The square root of 49 is 7. I'm not going to do that. Square root of 49 over the square root of 20. I don't want to have a square root sign in my denominator, so I'm going to multiply the top and the bottom by 20 just to get rid of it. So my denominator is now these are such ugly problems. Square root of 20 times square root of 20, square root of 400, which is 20. And then this chunk over here, it's going to be 7 root 20, which equals, what is that? 14 root 5 over 20 plus or minus equals x plus 3 halves. If you want to simplify this all the way, you have x plus 3 halves equals plus or minus 14 over 20 simplifies to 7 over 10 root 5. I want to go to bed. X equals plus or minus 7 root 5 over 10. Subtract 3 halves on both sides. And then they're fractions. You can have the common denominator. Plus or minus 7 root 5 times 5 is minus 15 all over 10. That's our final answer. Good? If you have questions, just call me. All right.